Oh, one, but yeah, we can go.
We'll go ahead and get started. Welcome, everyone. Thank you for being here. Happy New Year. It's nice to see you all, albeit virtually. This is the Climate and Food Systems mini lecture, the second in a series put on by the Colorado Consortium for Climate Change and Health, intended to help foster discussion and collaboration across our different campuses and among researchers working at the nexus of climate change and health. So we put together this panel today, and I will give credit here for the assembly portion to Jim Crooks, my co-director of the Climate Change Consortium, and Elise Grover, trying to bring together people working at the interface of food systems and climate change. And we have three people who are approaching this challenge from very different angles. We have Balaji Rajagopalan, professor and chair of the Department of Civil and Environmental and Architectural Engineering, who thinks about water and flooding and extreme weather events and how the hydrological cycle works, which is obviously relevant to food systems in terms of drought and the devastations of floods. We have Douglas Tarrin, a new member of the University of Colorado, faculty member at the School of Medicine, professor of pediatrics who thinks about nutrition, particularly in low and middle income countries. And then we have Jamie Butler Dawson, an assistant professor at the Center for Health, Work and Environment and in the Department of Environmental and Occupational Health at the School of Public Health, who thinks about heat and exposures among workers involved in food production, agricultural workers, primarily in Central America. So what we're going to do today is have each of our speakers give about a 5 to 10 minute overview of how they've been thinking about their take on this problem. And then we'll have time for question and discussion. We'll hold questions until all three speakers have gone. However, you are welcome to put them in the chat as you think of them. And Elise, Jim, and I will help to moderate the discussion once the speakers have finished. So we're gonna ask Dr. Rajagopalan to start. Just as introduction, Dr. Rajagopalan's research program is diverse and interdisciplinary, and I think a great example of how climate science and climate health can interface. He has 3 themes he works on: understanding the large-scale climate drivers of year-to-year and multi-decadal variability and predictability of regional hydroclimatology and their extremes. Second, developing ensemble hydroclimate projection tools. And third, coupling these projections with resource management and decision support tools. So Balaji, thank you for being here today, and I'll let you lead things off.
Thanks, thanks, Liz. Yeah, let me start it. Okay. Can you all see my screen? Thank you.
That's great.
Good morning, everyone. Yeah, thanks, Liz, for that nice introduction. As Liz mentioned, as Beth mentioned, I'm sorry, that I look at the interface from the climate side, variability of climate from at different timescales, and how it influences the water cycle and consequently all the other things such as food, health, nutrition, and so forth. So I'm going to give my remarks or a brief presentation from the tropical perspective. And so why tropics are important? So this is a map of where people live. Those big boxes are sort of the tropics, and those are also the places where rainfall comes in during summer as monsoons that we know. And about 2/3 of the world's population live there. So anything we talk about in terms of climate, in terms of nutrition, water, impacts a huge portion of humanity on the planet. And that's also the region of countries with marginal infrastructure, developing countries. So again, for really variety of reasons, tropics are really important, certainly from an impact point of view. Of this, the largest is in this bigger box, which is the Asian Australian monsoon, and I would say it's mostly the Indian monsoon that's sort of the more important. This is a quick schematic of how the Indian monsoon comes about, just to sort of orient you to the geography. The red big blob is the Himalayas. The monsoon winds come from the equator. They deflect off of the coast of Africa, and then they go towards India, the Indian subcontinent, and they provide rain. And as they hit to the bottom of the foothills of the Himalayas, they give up all their moisture, and then the dry air starts sinking. And where the dry air sinks, which is the blue ribbon, that's where you end up getting dry, mild weather, which is northwest India, Pakistan, Afghanistan, and Saudi Arabia, and so forth. So this happens, as you can see, the rain comes during June to September. So that's where it's almost like our snow system here. We get all the moisture during the winter, and then you have to use that moisture for everything until next winter. Same thing here, monsoon rainfall comes, and then you have all the water until the next year. So the monsoon has been a major driver for lots of things in that region. So it's been there since millennia. People have used and known about the monsoonal winds. As you can see in the right panel, the winds change direction. In January, the winds blow from the land towards the ocean, from India to the Indian Ocean, and then in July, the winds reverse. And so that's why the Indian monsoon is in its own class, because this is one place where the winds shift directions 180 degrees. On the left panels are sort of indicating how societies have used this to move trade, ideas, religion, agriculture, everything. And so it's really, really fascinating that the monsoons are sort of also sometimes referred as the maritime Silk Road, connecting Mesopotamia all the way to the civilizations in the Far East. Something that I've been working on is the rise and fall of Indus civilization, which is one of the oldest civilization. And this is apropos for our discussion because they were agrarian society, and the rhythms of the monsoon led to their rise and then subsequent decline and collapse. So again, interesting question is, why did this happen? What is the role of climate and environment in conjunction with societies in terms of their rise and fall and decline? This is a picture showing the Indian rainfall and crop yield. Top right, you can see very tight correlation. So much of agriculture over India is rain-fed, and it's at the vagaries of the monsoon. You get good monsoon rainfall, good agriculture output, and vice versa. So as you can see here, 20% of the GDP of India's GDP is affected by the monsoon. So monsoon really plays an important role, and consequently, agriculture, food, nutrition, everything down the line. Also with health, clearly a lot of the climate drivers are sensitivity, climate sensitive vector-borne diseases. As you can see over India, again, they have high mortality from this. So the rainfall or lack thereof also impact the health of individuals and of public and humans, in addition to health of the crops. This is kind of just a quick schematic to show what kind of the broad spectrum of diseases that usually crop up during monsoon all across the country. And I'm sure this audience is more familiar than I am. So again, knowing the variability of monsoon is really important. Just to round out, again, relationship between rainfall with other diseases like malaria, dengue, not surprising, goes with the rhythm of the monsoon. There's also some work we've done with Rick on linking the monsoon rainfall and temperature with the chronic kidney disease in that part of the world. Rainfall is decreasing over time and temperature is increasing, not surprising. And so that has important consequences for the society. This is future projections, and then I'll stop and I'll tie things up. Basically, everybody's familiar future projections are projected to be warmer and humid, and much of it is in the tropics. So tropics are not only going to get more dry, but they're also going to be humid, and the rainfall decline, but more extremes. So all the classic things that we are seeing. And so this means it has implications for mortality, implications for agriculture. And so I'll quickly scroll through. This is to show the extreme precipitation and heat waves increasing through this century. Let me skip here. So this one shows the relationship between rainfall, temperature, and rice yield. Rice is one of the staple diet and crop there. So change in precipitation, decline in precipitation on the left side, increase in temperature, you are looking at anywhere from 12 to 20% decline in rice yield. And that has major consequences. As I mentioned, that's the staple diet for majority of population, particularly in South India and also most of India. And likewise, increase in heat spells directly impacts mortality because they don't have air conditioning, and you end up with a lot of deaths during the season before the monsoon when it is really hot. And this one shows how 1 degree change in temperature leads to changes in different crops. Again, the yields are all projected to decline: wheat, rice, maize, soybean. So I'll end with this challenges. I think for public health, you don't need to have the rainfall really decline significantly. Even temperature increase can lead to societal tipping points. And that is something that policymakers are slowly realizing, because in India, there's always this perception, yeah, we are used to the heat and we can take 1 degree warming. But what they don't realize is that, yes, the rainfall might not decline to like 50% below what we are seeing, but temperature increase can really wreak havoc on the infrastructure there, both agriculture, public health, and could lead to societal tipping points. So thank you. I will stop there.
Thanks so much, Balaji. That's a great introduction and overview of the ways in which heat and temperature are changing and the potential impacts. Next, we're going to introduce Dr. Doug Tarrin, who, as I mentioned, is a new professor of pediatrics in the section of nutrition at the University of Colorado School of Medicine. Dr. Tarrin is interested in domestic and global food security issues, including local food systems, clinical and public health approaches to child weight management, the evaluation of humanitarian food aid programs, and dietary interventions. He has a range of ongoing projects, including looking at the impact of solar market gardens for small landowners, the interaction between food safety and nutrition, and how food systems impact the development and risk factors for type 2 diabetes in children. So Dr. Tarrin, thanks for being here, and I'll let you take it away.
Thank you. I want to just start off by acknowledging people I've worked with that kind of bring my thoughts together. The work in Benin and solar market gardens were done with Dr. Burney, Dr. Naylor, and Dr. Alaofe, and I've been working on some ecosystems work with Dr. Variboda, and food security work with Tim Frankenberger. And then since I've been here in Colorado, I've been working with Sarah, the nutrition section, Nancy Krebs, and others, just to get my thoughts around the role of climate change and nutrition. Let's see where. Get to the next slide. Let me say that I have 3 main principles related to climate change and nutrition. First, the climate affects what we eat. Climate change will change what we eat, and what we eat affects the climate. So if we keep these 3 tenets in our minds, I think that can help guide us. How do we want to approach nutrition and climate change? I approach climate change and my work around the issues of food security. And the ideas in using the FAO definition of food security, allowing everyone to have food at all times that meet their social and economic access to be, healthy. And so food security is sort of the basis of how I approach nutrition overall, and therefore how I think about climate change. And if you look at what may be affecting food security in the future. These are the 10 likely most important risks, I think, about climate change and food security, and extreme weather and the variations between super droughts and super monsoons, the extremes that we're having, our failure to have action regarding climate, the environmental damage it has on people, its interaction with infections, as we just heard, the loss of biodiversity that's occurring in the world, our digital power concentration, and needing to increase the equality to the digital age, because that can be used for monitoring and evaluations of climate change. How we work across states means nations, and how that's getting more fractured over time. The role of cybersecurity may involve with how we monitor health and climate, and then just making sure we keep livelihoods available to everyone. And so I look at the role of climate change and nutrition along the issue of food systems. And there's an issue, the linkage of food systems from the farm input all the way to the consumer is an important aspect of how I look at how climate can affect nutrition outcomes. And so a lot of the work I've been looking on with ecosystems around farm input, but again, on each of these steps, the production, the manufacturing, wholesale, logistics, transportation, all that can be affected by climate, given changes in weather and how we have access to income. So one of the things I've been working with Dr. Varivoda with is some models about how they look at food systems and natural hazards. And if you look at the inputs here, inputs, production, harvesting, post-harvest storage and transportation, retailing, and ultimately the consumer, cooking and consumption of food. And then how does climate or natural hazards affect these areas? We have physical damage, loss across the food value chain, and the impact on livelihoods and food security and nutrition. And I know this is a busy slide, so I'm just going to highlight how I look at how these affect the consumer. One is we can get damage to food preparation facilities, contamination of water and food from the direct damage of natural hazards like floods, hurricanes, things of that sort. We have loss across the food value chain, which we have increased household expenditure. So as food becomes less available, it becomes more expensive, and those who are already at the margins of equality and food security, they are hit with a bigger shock. And finally, we have the impact on livelihoods and food security and nutrition, because we have reduced food consumption and dietary quality of food because of climate change. And so these are areas that we would like to impact and make more productive for individuals. At the same time, we look at how we look at shocks. We can anticipate shocks to the resiliency. We can prevent them. We can absorb them. We can adapt, and we can transform them. And all of this comes from actually work by Tim Frankenberger too, at Tango International in Tucson, who I've been fortunate to work with. And then we can see how do these areas, how do we adapt, for example, to improve our food resiliency? And one is we can learn, that's the definition, from adapting, we can create more knowledge, we can create new types of foods. We have the ecosystems that we can adapt. We can increase the food and nutrition security and profits. We can create different types of foods like biodiverse, biofortified foods, to improve the diversity of our diets, improve micronutrient intake, which then yields to nutritious food and feed crops for livestock, for people. We can look at how to expand our food diversity by preserving wild game in low and middle income countries, by getting energy from manure, from solar, from bodies of water to help improve our nutritional status. So the solar market gardens I've worked on in Benin were first developed by Dr. Jennifer Burney when she was at Stanford. Now she's at UC San Diego. And she developed a system where you had solar power panels with a borehole that pumps water into a cistern that then goes into drip irrigation systems. These solar market gardens are managed by women's groups in Benin and West Africa. We have studies going on with 8 intervention communities and 8 control community or comparison communities, where these have been put into place, and over pre and post evaluations have shown that they've increased crop production because now they can do 2 harvests a year compared to 1 harvest a year because of the dry season. Now they can pump groundwater into their, with the cisterns into their fields. They have increased income, which they're using to send kids to schools. We've shown that it's changed their empowerment, and that women's empowerment is also related to nutritional status. And we have outcome measures to show improvements in the nutritional status of mothers and children. And I am not showing the data because just want to give you an overview about what's happening. What we need to do next is we want to expand these solar market gardens into additional communities, both in Benin and other parts of the world. We need to do more timely nutritional outcomes. And we want to see how we can get those who use these solar market gardens to increase their crop diversity. And that's because crop diversity is decreasing. The number of varieties of crops has significantly decreased over the last 100 years. And so in terms of ecosystems, which is really the natural environment, we want to see how to use the natural environment to promote food system diversification. What other types of foods can we use to increase biodiversity? Looking at studies in these areas, increasing the cohesion between technological innovations and nature-based solutions, and utilizing traditions and local knowledge to increase crop production. And then more locally, with people in the nutrition section, these are 3 questions I've pondered over the last several weeks, because I've only been here a very short period of time. But does knowing the carbon footprint of food items get someone to purchase food that lowers the environmental impact of a diet and improve the diet quality? And we're thinking about how we could answer this question. And can a school create a monthly menu that has a reduced carbon footprint that improves various outcomes like school performance, less childhood obesity, maybe integrating it into the curriculum and improving attendance even. And then does eating a lower carbon footprint diet relate to better nutritional status in children? A paper just came out in Journal of Clinical Nutrition that showed that the Lancet Eat diet, which is one that's based on environment, was related to improving mortality and morbidity in a Swedish cohort. So these are some of the questions I've been wondering about and the types of studies I hope to do in the future. So that's what I have to say.
Thank you so much. That was excellent. Last but not least, we have Dr. Jamie Butler Dawson, who is an assistant professor at the Center of Health, Work, and Environment, and sits in the Department of Environmental and Occupational Health at the School of Public Health. And she does work at the nexus of occupational health and climate change, really looking at the impacts of extreme heat on agricultural workers in Central America, and I'll let her go from there. Thanks for being here, Jamie.
Thanks for having me on the panel. So I'm going to dive right in. You know, I think my news feed is probably biased, but I feel like daily I see I see news with headlines saying, you know, showing the extreme events and the impacts on worker health. So here's just a smattering of headlines that I've seen in the past based on heat and also fires, landslides. So workers are definitely in the news lately. So why are workers so vulnerable? Workers' exposures are often greater in frequency, duration, and intensity compared to general populations. And they also can escape these hazards, or they get fired, or they don't make the amount they're supposed to make each day. So they are pretty vulnerable when it comes to exposures. Climate change does intensify their already existing workplace safety and health hazards. So we have heat stress, extreme weather events, exposure to hazardous chemicals and pathogens, and they've already been exposed to all this, and then climate change is just intensifying all these exposures. And then of course there's other indirect impacts. We have workers' well-being, their work performance maybe goes down, poor mental health, decreased productivity, a shift in working hours, and then also an increase of risk of injuries and then diseases. So just a bigger picture here, looking at heat and productivity in agriculture. So high temperatures will lead to less productivity and less labor supply, which also leads to lower food production and higher food prices locally, nationally, and worldwide. So this figure is from a paper that our team published here at the Center for Health, Work, and Environment, looking at sugarcane cutters in Guatemala. So on the y-axis, we have average wet bulb globe temperature with increasing temperature, and then also average amount of sugarcane cut by these sugarcane cutters, and that's measured in tons per day. And then on the x-axis, we have just the harvest season, which is 6 months long, starting in November all the way to May. So basically, this figure is showing that as temperatures increase, the productivity and the amount of sugarcane they're cutting goes down. And then if workers had reduced kidney function at the start of the season, that the relationship between temperature and productivity was amplified. So they had workers that already had a compromised kidney health. They weren't able to cut as much because the heat was affecting them more. And also the workers that had poor kidney function, they were less likely to finish the 6-month harvest. So they were quitting early, which is attrition, which is another loss in productivity. And then I just read that this, the Lancet Countdown, this huge number, was 295 billion hours of potential work lost worldwide in only 2020 due to heat exposure. And the majority of this was in a low human development index country, occurring in agriculture. So I just wanted to briefly discuss a couple studies that I'm involved with currently. So there's an R01 in our department looking at particulate exposure and kidney health. The PIs are Dr. Lee Newman, John Adgate, and Josh Schaefer at CSU. It's a 5-year study. It just started. We just had our first initial time points in the fall last year. So the study population are male sugarcane cutters in Guatemala and Southwest Guatemala. So we're looking at occupational airborne exposures. We're also looking at occupational heat stress as well as dehydration. And then another part of the study is looking at worker recovery at home. So you have intense heat during the work shift, and then when they go home, do they recover from their day at the job? And DRPH student Lindsay Kreischer is the PI for this portion. And then I have a KO1 looking at women's airborne exposures and kidney health in Guatemala as well. It's a 3-year study. And the study population are female seeders that are hired by the sugarcane company, and also female community members that aren't involved in sugarcane at all. And we're looking at occupational exposures. So with the female seeders, what do their exposures look during their work shift? And then also when they go home and they have a day off, what do their exposures look like? And then we'll do the same with community members that aren't involved in sugarcane. So we're looking at airborne exposures as well as heat exposure. And this, I think Rick Johnson's on this call, but this is his figure from the New England Journal of Medicine. But this is looking at just possible mechanisms for the development of Mesoamerican nephropathy, also known as chronic kidney disease of unknown origin. But our studies, the R01 and the K, will be looking at multiple areas. So looking at the exposure of toxins and toxicants like pesticides, silica, metals, and then looking at heat exposure. So we'll be looking at dehydration and then increased core body temperature and how these all synergistically affect kidney inflammation and kidney injury leading to CKD-U. So these pictures are from the field in December. So you can see that they do have a lot of airborne exposure. So they burn the fields before harvesting. So here we are collecting urine and blood samples from a group of workers, and then nearby they're doing an intense burn to get the sugarcane ready to harvest the next day. And I thought that was pretty intense heat, just striking how close it is to the workers as they're doing intense labor. And here's a cane cutter, and he's covered in ash and soot. And it's just, this picture just shows like just how dry it is and how hot and how much particulate matter is in the air. So we will be measuring a number of pollutants for these studies. So for the R1, the MIN study, we are putting running vests on them and then attaching the individual air samplers to the running vest. And these are the cyclones that we've decided to use. And this is put in their breathing zone to measure what they're breathing in, essentially. And this little thing here is called an I button, and that measures individual ambient temperature and humidity. So the cyclones here are going to be measuring particulate matter, silica, metals, glyphosate. So they're going to be wearing this setup throughout their whole work shift. And then the women for the KO1 are in a similar setup, wearing the running vest. We're going to be using the cyclones as well. And then they're also wearing silicone wristbands. So I had the women wear these wristbands for 7 days in December to look at occupational and household exposures. And that's looking at, it looks at over 1,500 organic chemicals. So it's an untargeted approach, whereas the air samplers are more of a targeted approach. And then this is how we're measuring heat exposure. So we have field wet bulb globe temperature with this kestrel here in the field. And then we're having the male workers swallow a core body temperature pills to look at their core body temperature throughout the work shift, and then throughout the night for Lindsay Kreischer's study. And then we have the eye buttons that measure the temperature and humidity. And then in terms of future research goals, so both studies just started last year, but we're hoping to examine relationships between field and individual climate metrics, like the core body temperature and the field measures. We want to explore synergistic exposure effects on the kidney outcomes, and then assess exposure effects on worker health and well-being and productivity as well, continue that line of research, and just hoping to, in the future, build on our existing worker health and safety interventions in Latin America. So we've done interventions increasing water, electrolytes, rest and shade with these workers, and then we're doing kidney and injury surveillance continuously. And here's a couple of our materials from our past studies. And then future directions. So OSHA is in the process of the Occupational Safety and Health Administration. OSHA is in the process of making new heat-related standards to protect workers, and this is just the initial phase. So they're asking for public comments, and some of the questions that they've been asking people in this field are, there's a big question like, how should climate change be factored into the OSHA prevention standard? And then a little more specifically, like, how should we define hazardous heat exposure in workplaces? Like, what metrics should we be using? Like average wet bulb globe temperature, heat index, and then looking at different regions of the US. And you have pervasive heat hazards like in Texas, Florida, where there's constant heat, chronic exposure to heat. And then you have the heat waves, maybe in like New England when there's a heat wave. And should we be looking at health effects the same way and heat exposure the same way? And then also looking at effective thresholds for preventing illness and fatalities with the workers. So should we be looking at multiple thresholds? It gets really complex fast. You know, are we looking at both air pollution as well as heat? How do we decipher the difference, or should we combine? And then lastly, you know, are there specific worker populations that have disproportionate exposure or outcomes? And I think that's it. I just want to acknowledge the large team behind this research here at the University of Colorado and CSU, and then the sugarcane company that we work with in Latin America.
Thanks so much, Jamie. And I think we'll open it up for questions now and discussion. And if you do have questions, feel free to either unmute yourself or to put your questions in the chat. And I'll start as others are formulating a question. Or Jamie or Doug, were you unmuting because you have questions, or you? Okay.
I'm just getting ready to answer any questions that show up.
I have a question kind of for the around forecasting. So, you know, one of the things Doug talked about is this ability to anticipate shocks, and this can be to heat extremes or more longer term drought or extreme weather events. And, you know, maybe both from your different perspectives, what's the, you know, maybe Balaji, you can comment on kind of what's the ability for us right now just to anticipate what the future may hold in the short term, like how well can we forecast either seasonal or in the weeks ahead when there's going to be these extreme events? And then are there ways in which we can work to protect workers in those extremes? Kind of, this is on the adaptation end of things, but how well can we anticipate those shocks and protect workers or the, you know, ag investments and production outputs?
So on the climate extremes, there is quite a bit of predictability for some of these extreme attributes. But most of the forecast projection, at least in the short term, like seasonal, have largely focused on seasonal average rainfall, seasonal average temperature, and they are useful because that's what people have historically relied on, particularly, for example, say in the case of Indian monsoon. Everybody is focused on the monsoon rainfall total. And so there's lots and lots of work for more than 100 years since when the British were there to model and try and predict that seasonal total. However, what has happened now is since agriculture has evolved, there is need for more nuanced forecasts, such as what is the distribution of that rainfall within the season? Will you get a dry spell during the early part of the season when the seeds are put in? Will you get a big flood when the crops are standing? I think there is now more need for those kind of nuanced extreme events, but at different times within our subseasonal. And so there's quite a bit of work being done, and there's lots of statistical techniques that are emerging, which some of which that we have been working on and using to understand space-time variability of extremes. As to the projections, right now, most of the projections are based on the climate model outputs. And there is potential for improving using models built on existing or contemporary period, and then using those models in conjunction with climate model projections for future extreme events. So yeah, definitely there's lots of scope and potential now with new methods coming online, statistical and otherwise. So I think we can we can definitely help make those. And of course, a lot of them will be probabilistic, so which means you have to resort to risk-based decisions.
Jamie, do you want to weigh in from the worker perspective? If we were able to forecast these extremes, and would anything change? And what?
Yeah, you think of it as how the employer would want it, and how could we best protect these workers? And if an employer or a certain industry could project and say, okay, long-term or medium-term, this is coming, and budget for protection efforts, which is sad because they do need advance warning to budget for all these things, but yeah, that would be, I was thinking just now of a software package where, I could, if I was an industrial hygienist at a company, be like, okay, I live in this region. These are the hazards they face. What do I need to think about this upcoming season, and think about the weather? And I don't know if Miranda or Lindsay, you want to chime in. I know, Miranda, you've thought about modeling a little more.
No, I mean, I don't think I have anything to add than what you just said, Jamie. I think it would, from our perspective with work, it's having that ability to maybe be a little bit more responsive rather than reactive. But other than that, yeah, I don't think I have anything to add to it.
Thanks, guys. Cheryl, it's nice to see you on the call, and I see you have your hand up.
Hey, Beth, thanks. Yeah, thanks for calling me. Great talk, everyone. It just also, I think, Jamie, some of your pictures also highlight the fact that our talk on wildfire smoke, whether it's prescribed burns, agricultural burns, isn't separate from all these things that we're talking about climate. But I had a separate question. And Doug, I think I might pose this to you. Are there projections given kind of a burgeoning middle class in like China, Brazil, especially about the demand for animal-based protein and what that might look like for climate projections as well as nutritional projections? It feels like there's a little bit of tension there. And I didn't know if you could speak to that.
I can't speak directly to it. I can tell you that the demand for animal-based foods is definitely increasing worldwide, as you sort of alluded to. The impact that it can have on climate may be significant. Well, I'll give you an interesting example. In Arizona, the Saudis own all this land and they grow hay, and they grow it in Arizona and they ship it back to Saudi Arabia to feed to their cows, so they have increased their dairy production. That just seems like an incredible carbon footprint to me, to be willing to do something like that. So I think that's another example about that demand for animal source foods and how it can impact on climate.
Yeah, that's a great example. Wow. And just to follow up with that, is anyone working locally? We have these great examples, especially from international, but I know that one of our main agricultural products here is cow, beef and dairy, as well as lamb. So anyone engage with any local work with producers? Or I know Kim Stackhouse-Lawson here at CSU is doing some, but I didn't know, it's more focused on working with the producers rather than working on the health and kind of long-term benefits.
Not aware of anyone. I don't know if anyone else is, but I do think it's an interesting potential angle, especially as we think about the consortium and work moving forward. I know Jim and I really value building partnerships within Colorado. So anyone chime in if they know anything else.
Not just to kind of make a point from agriculture in India. Two things that's happening is, one is with climate variability and change, there is push on the policymakers to come up with policies where crops are grown in the right places. For example, right after the British left the independence, India got independence, this was in the mid 40s and 50s, there was a big push to make self-sufficiency for food because there were famines prior to that. And so there was a massive effort where the government said, if you produced rice and wheat, which are the two staple, we will just buy it and give you a minimum price. So farmers started producing these all over the place. Fast forward now, what's happening is they are producing rice, which is an extremely water intensive crop, in places where it just doesn't make any sense, which is North India, where it's generally dry or semi-arid. And so it has now led to groundwater depletion. It has led to all kinds of other environmental issues that were not envisioned at the time. And now climate, in conjunction with the incentives, are pushing people to doing things that can be really bad. For instance, Northeast India, where there's a lot of water, would be a great place to move some of the rice production, but that would require policy instruments to change. One last point I'll also make is that there's a lot of dry crops which are nutritious, and the native population, both in South India, South Central India, have been using, and they have been consuming for generations and millennia. Even they are moving into, as they move up the society, socioeconomic ladder, they start moving into more animal protein. And so I think going back to a concerted campaign to highlight the virtues of these crops, which are so water efficient, while at the same time providing a lot of good nutrition, I think is very important. So some marketing, and so maybe a good collaboration with business folks as well.
Thanks, Balaji. I want to ask Dr. Krebs' question that Jamie and Nancy have been chatting about, but Jamie, do you want to talk a little bit about the mitigation measures that are effective for workers to protect them, and how you might test those interventions?
Mm-hmm. With the sugarcane company, a couple of years ago, based on our research finding, we found that hydration helps. It reduces their muscle breakdown and improves their kidney health. So we worked with the sugarcane company to pilot a couple interventions where one intervention was increasing the amount of electrolytes that the workers took in during the work shift. So before they were only provided a small amount of electrolyte solution. So we increased that amount in a pilot, and we looked at what would be the optimal amount of electrolytes for the workers. So we had a pilot that was 3 weeks long. We had baseline business as usual, and then we increased their amount of electrolytes to 5 liters a day, and then the third week was 10 liters per day, and then we looked at outcomes. So that was one way we looked at it, and then we saw that yes, the workers liked more electrolytes, they did better, less muscle breakdown, and then we worked with the company to implement that intervention for their entire field workforce. So that was one way. We also did a pilot. We shifted. Well, what did we do, Lindsay? Like blinking, COVID brain.
Yeah, we tested out a different schedule. So having them take more short breaks in the afternoon and kind of working a longer period of time continuously in the morning while it's cooler.
And then, sorry, Lindsay.
Kind of results were kind of mixed with that because we didn't really see what we expected to see, I guess, if I remember correctly. In terms of heat stress, yeah.
And I know the company has tried to have different work shift hours, so they tried to have the workers cut at night, and the workers hated that. You're using a machete at night, and then there's a lot more vermin in the field that could bite them. So they decided not to do that. And we've slowly been trying to convince the company to give the workers salary and not pay them by the amount of cane they cut.
Thank you. This is Nancy Krebs. I'm sorry, my camera isn't working. But I just wanted to indicate that part of my question was about these workers, but also as we look at the health effects, start to really document health effects of heat stress and so on, that what do we do about it? I mean, it's one thing to document the effects, but then those mitigation strategies. And so I just was curious your strategies are very interesting to hear and what you've tested already. So thank you for sharing that. And, because I think we need to be mindful of that.
And I didn't mention, but we worked with a company too. So they had pre-employment screening where they check the health of the workers before they start cutting for the 6-month season. And they implemented a more conservative cutoff for kidney health. So the workers have to be healthier in order to start the season. And then they're doing kidney surveillance in the field as well.
Great.
Yeah, this is Doug. I was wondering, are you looking at any type of clothing, protective clothing, things that can keep them cooler while they work? I know they do that for firemen, about just ways to have this heat have less of an effect on them.
Yeah, and I know that some studies in Florida had the cooling vest on the workers, which I think is a great idea. I don't know how sustainable that would be in low resource countries, but I think it's something to look at, other ways to cool them. And there's always local cultural beliefs that cold water might make them sick. So it comes with a lot of education. But yeah, we should look into other techniques to cool down workers.
There's also an advocacy role here. Lee and I went down to Mexico and we met with the head of their Social Security system, which is the system that provides health care for these workers. And what tends to happen is that as these workers develop their chronic kidney disease, they're less able to work, and they're let go or they stop themselves. And then because they're no longer working, they're no longer eligible for benefits under the Social Security system. So if their chronic renal disease is diagnosed while they're still working, then they're eligible for care, including eligible for kidney transplants or dialysis. But if they quit before anyone realizes that they're quitting because of the fatigue and ill health related to their chronic kidney disease, they don't get anything. So I think that there needs to be routine screening of all of these workers. And then once they're identified as having chronic renal disease, there needs to be ensured that even after they leave their job, their Social Security healthcare system continues.
I think this is such an important point. I think this is a little bit of what Cheryl was saying, and Nancy and Jamie were going back and forth on in the chat as well. This kind of the high level structural change, the level of interventions which can be implemented. And I guess I wanted to go to kind of the highest level intervention, which is the mitigation piece in terms of emissions and slowing down climate change. And I think what's so interesting about the food production cycle is it has all these vulnerabilities and can be impacted by climate change, but also obviously can impact climate change from the consumption, from the demand end of things. And I don't have any solutions or a well-formed question here, but I'm curious to get your thoughts, and maybe Doug, you've maybe spent a little bit of time thinking about this from the nutrition end of things. Is there a role to play in kind of advocating for these lower carbon diets, recognizing that in some places people need more protein in their diet, and in other places people probably could benefit from a whole lot less? And
yeah, it's interesting because right now there's places in Europe that actually do put the carbon footprint of food on labels. I'm not sure what type of impact it's having as far as people choosing different products. I think you also have to regionalize. I mean, we're talking about the US, or you're talking about being in a village in Guatemala or in West Africa. That you can increase protein consumption multiple ways. You don't have to transport it long distances. There's different types of foods. I was several years ago, probably many years ago, I was reading about iguana farms as being a good source of protein. I've had iguana, by the way, in Panama, and the reason to have iguana farms is they preserve the forest. You need the tropical forest to have the iguanas grow. So you're sort of getting a high conversion of plant protein to animal protein. It's locally produced. It's a culturally high valued food for different occasions, for example. So it just depends on how you're looking at where you're producing it and how you're consuming it. And but there are ways to reduce the carbon footprint of food. We just have to be able to figure out people are going to be on board with it, and then different mechanisms for it at the same time. I'm not sure that totally answers your question, but those are sort of the thoughts that first came to my mind.
Yeah, it seems like Nancy's echoing some of those comments in the chat too, that it's not a one-size-fits-all solution for different people have different dietary needs. Absolutely. I think those who have worked on cook stoves can also appreciate the challenges of telling people to change how they cook and change how they eat. Is cuts to the heart of so much of our own identity. These are not easy.
Yeah.
it's interesting because you're talking about cook stoves. I had a project in Peru where we were basically trying to figure out how to help villagers to make stoves that had chimneys coming out of their house. They were breathing all the smoke inside their house as they cooked. So simple interventions. It may not have improved if you had maybe a catchment on top of that chimney to capture some of the carbon that's going out, the particulates. You could be improving both what people breathe in the villages and inside the house too, both inside and outdoor pollution.
Well, we're closing in on the end of the symposium. I am curious if anyone has any final questions or comments, and please feel free to put them in the chat or speak up. But I wanted to give a special thanks to our three panelists today, Jamie, Balaji, and Doug, who really did an excellent job of tying these, looking at this problem from different angles and helping us tie them together. I'll note that the Colorado Consortium on Climate Change and Health is hoping to put together another mini panel lecture and discussion in the next couple of months around policy. And so if people do have thoughts or ideas or suggestions for another topic that we could handle, please reach out to Elise, Jim, and myself. And I just want to say a special thanks to Elise, who really did a lot of the legwork to put this session together. So thank you for your work in that regard. We look forward to seeing you all in the future. We'll leave the line open for a couple minutes if anybody wants to chat. Thanks all for being here today.
Thank you.
Yeah, thank you.
Thanks for putting it together.
Yeah.
This was great, guys. Thanks.